Well, okay, so that was the Titan 3C program. And I think I worked on that program for maybe 2.5 or 3 years down at this Coyote test facility. But the program petered out. Basically, UTC had done its thing. We had developed the motors, all of the technology with the actual propellants and the cases and the nozzle and the thrust vector control system around the nozzle, the TVC system. And the thing was ready to fly. Well, we had nothing to do with the flying of it, with the operations. And so people were getting laid off from the Coyote site. And me being one of the young guys, you know, I was at risk. So I went looking around, and I had a very nice boss, and he went looking around for me too. And the net result was that I transferred to the research and administrative facility for UTC, which was in Sunnyvale, a bit north of San Jose. So I'd been living in San Jose all this time. I'd been going south to Coyote. Now I was just going north to Sunnyvale. And that was an interesting experience because they were doing up there like the basic research for rocketry. They would, you know, and UTC was all solid rockets. So it started with basically propellant formulations, you know, what kind of stuff burns well, creates a lot of thrust, has a controllable burn. You can actually light it, ignite it reliably. That can be a problem with big rocket motors. Actually, on the big one that I was talking about before, the way you lit that thing off, there was a small rocket motor in the nose of this big rocket motor. The small rocket motor was not to produce thrust. The solid rocket motor burns from the inside out. So it's like a hollow cylinder of propellant. So you light the inside, and then it burns from there to the outside. Well, to get it to light, you'd like to get all of it burning at the same time, right? You don't want the nose to burn and then so you've got to have an igniter that will create a 50-foot long plume that's uniform and that's really hot enough to get the big stuff going. That's a whole nother development program all by itself. Not easy. So up in Sunnyvale, they were doing stuff like that. They were doing basic propellant formulation, you know, like, let's try this. And the way you do it is we used to fire what we called teeny motors. They start out, they were a couple inches in diameter, maybe a couple inches tall, with a cute little graphite nozzle on the thing. And we had a test facility with bunkers, very heavy concrete on 3 sides, with the firing stand in the middle. And you'd fire these things off, and they'd basically go, and it was over. But in that little, we would measure the thrust, the pressure, the flows out the nozzle, and stuff like that. And then, now, again, I was just the instrumentation guy, but at this point, I was the engineer in that little facility with a bunch of really good technicians there. And so we would make the measurements and do the very rudimentary first data analysis, and then, you know, hand it off to the propellant guys, basically, and they would do whatever they did with it. But that was very educational because, of course, this was like 1964 now or so, days before digital instrumentation. So we recorded the bulk of our data on light beam oscillographs, which, thank goodness, are long gone. But the idea is it's a super tiny, super light mirror that is swiveled in direct relation to an electrical signal going through it. So you take the signal from the transducer, the pressure transducer, the strain gauge, whatever it is, the load cell, and you route it into this light beam oscillograph with multiple of these little mirrors, and they deflect, shine a bright light on them, which reflects down onto a photosensitive piece of paper, and you get little squiggly marks on the paper. Wow, how crude. So that was the way we recorded most of the data. And then we had some interesting projects too. I think at that point UTC was kind of looking for anything that came along. So some really oddball stuff. One of the ones I remember was a propellant system for what was known as the Sandpiper drone. And this was a target drone. So it was a rocket-powered kind of like third scale airplane that flew pretty darn fast. And the artillery guys would try to shoot it down or fire anti-missile missiles at it and that kind of thing. So the idea was it was expendable and it had to be cheap. And so there was first a propellant development program. And I think the propellant was a byproduct of making plexiglass. So it was one of these things that would get thrown away ordinarily, and UTC's going, maybe we could burn that stuff and make a rocket out of it. Well, that was a great idea, except the stuff was darn near fireproof. Once you got it going, it would work as a propellant, but it was very hard to get it to ignite. And we actually almost had a really bad accident. Again, I say we. I had nothing to do with it. But one of our guys back there in the bunker area was the igniter expert. And the igniters that we usually use, and we use for the teeny motors and the up to 10 pounders, it was a solid material that was impact sensitive. We actually lighted it off with a hot wire squib, but it was impact sensitive. And Angelo was the guy's name, had his own lab for himself because this was dangerous work. And he one day dropped a bag of these BKNO3 pellets. The bag was about this long that we were trying to use for this Sandpiper. I mean, for a teeny motor, there was just one little grain of BKNO3 that would light it off. But he was working out in his lab area or his work area one day and dropped one of these bags. And he walked through our area, the main area where the other desks and stuff was, just white as a sheet, and just went home for the day. Didn't say anything. And we found out later what had happened. He could have been killed. We could have all been killed. There was some danger involved. We had some motors go bad and would crack the walls of the individual test bays and stuff. So it was a lot of fun, but it was kind of risky in a way. Anyway, the Sandpiper, we finally got it to light and to run. And I don't know if it ever flew, but it was just like pulling teeth, everything about that thing. Everything had to be cheap and therefore designed right on the edge. I remember one firing. This particular motor had a burn for 300 seconds. And I remember one particular firing where we got a hot spot on the side of the motor. The operators would look out a very heavy window, look out into the test bay, and we got a hot spot on the side of that motor. You could tell because it was turning brown. And it started, like an inch in diameter and ended up, I swear that thing was like 3 feet in diameter. And we had an old ex-Navy guy that was running the control board, Wally. And nerves of steel, I'll tell you, nerves of steel. And we saw the little hot spot growing, and the engineer in charge of the Sandpiper program was looking over Wally's shoulder. And by the time this spot got really big. He was pounding on Wally to shut it down, and Wally was just like there with his finger on the switch. But we needed to get to that 300 seconds, you know. We made it. We made it. And I've forgotten what the kid's name was, the engineer. But he went from pounding on Wally's back to patting on Wally's back. Wally was his friend forever. That was a lot of fun. I was there with UTC for about 4.5 years, nearly 5, I think. And it dawned on me that I was not really going to go anywhere in that company because I was an electrical engineer. And, you know, management and the higher ups, their skills were more aligned with what the company did. They were like chemical engineers or process engineers or something like that. And so I kind of looked around and said, I need to be doing something that's more directly aligned with electronics. Well, at that point, San Jose was the home of a big IBM plant, south end of San Jose on Cottle Road. I thought that's where I ought to go. I mean, it wasn't electronics per se, but, you know, computers and a lot of electronic stuff. And they had, I think it was called the Test and Measurement Department, which fit in perfectly what my background had become. I'd sort of become an instrumentation guy. And so I got a job there. I think Norm and I were newly married at that point. So that would have been like about 66, early 67 maybe. So we bought a little house in the south end of San Jose, and I commuted over to IBM, and it was perfect. I wasn't there very, very long because I got an opportunity, which I'll tell you about. But I worked on a very interesting program there. Again, I really didn't know because I was just a small part of the deal, you know. But now I realize that was kind of a pioneering program. It was called the IBM 1500 Computer Assisted Instructional System. Now, this was way before, you know, there were like personal computers in classrooms and stuff. But I guess IBM saw an opportunity. So this system was a mainframe. It was housed in a 19-inch rack. It was about 6 feet tall. I think it was the IBM 3300. I'm not sure what the computer was. The entire system was called the 1500 CAI. This central computer then drove up to 32 student stations. The part of it that I worked on only had 16, but I think it was expandable to 32. And each student station had a monitor. I remember that for sure. I think it might have had a keyboard. And it also had a slide projector, because if you go back to that era, computer graphics were not so good. So it did have a monitor. Maybe it was text only, I'm not sure. But then it had a slide projector, all controlled by the computer. And the input for the student was maybe that keyboard. I think there was a keyboard. But for sure, there was a light pen. This was before the time of touch screens and that sort of thing. So there was a light pen. The student could press that pen up against the monitor, okay? And the pen had a little switch in it. So when the student pressed it up there, it would start receiving. And of course, you know how CRTs work, so that it would scan and it could tell where in the scan you were, therefore where the location that they were pressing on the screen, and that was one of the inputs for the students. And then so, you know, like maybe the computer would show them a slide. There was a film strip and would show them a slide, and then maybe up on the screen would come some questions. I never really got into the content of it. We were involved with checking to see that these things worked properly. And oh man, they did not work properly. There were all kinds of problems. I mean, you can imagine it's a film strip. And so you got all the film feeding things, and the computer would give the projector the right command, but then the projector would screw up and bring up the wrong slide, or half one slide and half another. But the most fun problem we had a prototype system that was installed at the Ravenswood School in Palo Alto or someplace up the peninsula a ways. So they were checking it out with actual students. And the customer service engineers were going up there all the time. I'm sure their cars knew exactly how to get there on their own. So one day, the customer service guys got a trouble call. A light pen wasn't working. So they went up there to troubleshoot the light pen. Well, the problem had been that the kid had been out on the playground, stepped in the mud, used the light pen to scrape the mud off of the bottom of his shoe. And so the customer service guy looks in the end of the light pen, and he thought it was dog crap but it turned out to be just mud. And that was the trouble call. So I don't think, I'm not even sure that system really got off the ground. They did the prototype thing, I know, at Ravenswood. Whether they ever sold them or not, I don't know. But again, looking back on it, it was a very interesting program. And as the test and measurement guys, we would do not only stuff like that and the misfeeds on the slide projectors, but we did the normal stuff. So, we did like the equivalent of burn-in tests. We'd put the monitors in an oven and we'd get them really hot. And CRTs do not like that. And of course, when the image would distort, then the light pen would get screwed up. So it was great. It was great. And a good experience in the IBM, the corporate time. That was still a time when IBM was very formal. Everybody wore shirts and ties. And, well, we had worn shirts and ties. The engineering guys at UTC were shirt and tie guys. But we were pretty casual, And I remember early on, I'd probably only been with IBM for a few months. And of course, they're big on meetings. You go to meetings all the time. And I walked into a meeting and one of the guys says, "Well, there's Kipp with his colored shirt again." And it dawned on me, it was supposed to be a white shirt and tie. And I had some colored, like a light pastel something. Oh no, nobody told me I couldn't wear that stuff. But it was a comment. There's Kipp with his colored shirt again. So that was fun.